I'm Jeremy Norris, Director of Mass Spectrometry at Protein Discovery. In the next few minutes, I want to tell you how simple and easy it is to prepare your complex biological samples for mass spectrometry using our new Passport 1200 sample prep system. The Passport system consists of three major components: the Passport 1200 sample prep station, a benchtop instrument, the instrument control software, and the Passport RP sample prep cartridge kit that consists of a 96-well cartridge and buffer reagents. To begin, I'm going to load a cartridge with some serum samples. I'll unwrap the cartridge, remove the seal holding the buffer solution in each well, remove the buffer. Next, I'll add the running buffer in each well using a standard 8-channel pipetter. Then, I take my unprocessed serum and mix it in equal amounts by volume with the sample buffer provided in the cartridge kit. The system can accommodate any type of biological sample, such as serum, plasma, CSF, saliva, even tissue and cell homogenants. Since the system only requires a small amount of material from each sample, we typically load only 5 microliters of total serum. Today, I have 96 different serum samples that I'm going to prepare for MS analysis. Now, I'll pipette 10 microliters of sample solution, which contains the sample buffer, into each well. With my samples now loaded, I place the cartridge in the Passport 1200 station. Using the Passport software, I will select the sample preparation program for these samples and run the experiment. The computer can be in the lab next to the Passport station, or it can be remotely located, like in your office, communicating with the station through an Ethernet connection. The program defines the parameters of operation to capture the sample fractions of interest for each of the 96 samples. There are a number of predefined programs that we provide with the system. However, additional programs can be quickly and easily customized by you and stored on the computer for future use. Today, I have selected a program that applies 0.5 milliamps of current for 30 minutes. The beauty of the software is that each well can act independently, in essence having up to 96 different experiments going on simultaneously. This is going to run for 30 minutes, so now let me tell you what's going on inside the machine. This animation shows the critical components of a single well of the 96-well cartridge. Each well of the cartridge is an independent electrophoretic device. When the cartridge is taken into the instrument, a set of 96 electrode pins makes contact with the top of the cartridge. This clever design eliminates direct contact between the instrument's electrodes and the wet sample solutions in each well. At the pH of the experiment, we have both anions and cations in the well. When the run button is pressed, voltage is applied to each sample electrode. The direct current passes through each well according to the direction and duration specified by the software. In this experiment, we are capturing low molecular weight cations. The positively charged analytes in the sample solution migrate through the polyacrylamide gel layer toward the reverse phase capture layer below. Uncharged and anionic analytes remain in the sample solution. In addition to fractionation according to isoelectric point, the analytes are further fractionating according to their electrophoretic mobilities. The larger molecular weight cations remain in the polyacrylamide gel layer. The smaller molecular weight analytes are captured onto the reverse phase cartridge capture slide. The duration of the run determines the size of the analytes that get through to the cartridge capture slide. Let's go check on our run. The run is now complete and my samples are just about ready for mass spec analysis. I remove the cartridge capture slide from within the cartridge. The cartridge is designed to be easily disassembled into individual components. This graphic shows the individual layers of the cartridge. The analytes are captured on the reverse phase capture layer at the bottom of the cartridge. The remaining cartridge components are discarded. The slide is then rinsed to remove excess buffer salts and dried. My samples, which have been depleted of high molecular weight proteins, fractionated, desalted, and concentrated, are now ready for MS analysis. As you can see, the entire process has taken less than 1 hour. I plan to analyze these samples by MALDI MS. However, I can also use our sample extraction protocol if I wanted to perform additional high-resolution chromatography-based analysis. More technical information about our system can be found in our recently published paper in Analytical Chemistry. If you would like us to prepare some of your samples, please download the sample workup form from our website. Thank you for taking the time to check out the Passport 1200 sample prep system and for allowing me to demonstrate how easy it is to prepare your samples for analysis by MS.